the QRS complex, that is going to be the axis deviation. The axis deviation. So for the axis deviation is to know which is the dominant side of the heart. Normally we know that the dominant side of the heart is the apex. Is it clear? So normally the dominant side of the heart is the apex, and now the apex corresponds to a normal axis deviation. So when the wave of the heart goes to the apex, it corresponds to normal the normal axis deviation. So let's say that you have your heart as such. Is it clear? You have to know that, yes, let's say that this is the center, here's the apex. You have to know that the resultant wave must go in this direction toward the apex, and this direction is the direction of the normal axis deviation. Is it clear? Now, if the resultant wave goes more in this direction, you have more of a left axis deviation. If it goes more in this direction, you have a right axis deviation. And if it goes more in this direction, you have an intermediate axis deviation, or a far right side deviation, far right axis deviation, or a far left axis deviation. Is it clear? So those are the different aspects that you have to know. So from this, you must first draw back your vectorial representation of your heart. Is it clear? So here's your y-axis, here's your x-axis. Is it clear? You have to know that the limb lead 1 is going to be located here. The limb lead AVF is going to be located here. The limb lead AVR goes in this direction. AVR go in direction. Here is limb lead 3, and lastly here is limb lead 2. So those are the different leads. Now, in order for you to know the axis deviation, the first point is that you should know the directions where you have the normal axis deviation. So all these correspond to normal axis deviation. So from negative 60 degrees to a plus 90 degrees correspond to a normal axis deviation. Now from here to here correspond to a pathologic left axis deviation. Is it clear? So from the negative 60 to the angle here is negative 120 degrees. You have already visualized it. So from here to here, it corresponds to pathologic left axis deviation. Now from here to here, it corresponds to a right axis deviation. From a plus 90 to a plus 180 degrees corresponds to a right axis deviation. Is it clear? And lastly, from plus 180 to this angle here, that is negative 120, corresponds to intermediate axis deviation, or a far right axis deviation, or a far left axis deviation. Is it clear? That is the first point that I want to understand. Now let me clarify something. Every axis deviation, that is right-sided axis deviation, are always pathologic. Are you understanding? Now, every axis deviation, that is intermediate axis deviation, are also always pathologic. And lastly, you have to know that the left axis deviation can be either pathologic or non-pathologic. If the left axis deviation is located on this side, from the negative 60 to negative 120, it's going to correspond to a pathologic left axis deviation. But if it is in this side here, from plus 0 to negative 160, is going to be corresponding to a physiologic left axis deviation. Is it clear? A physiologic or a non-pathologic left axis deviation. Now, this physiologic left axis deviation, you see that it corresponds to a part of the normal axis deviation, so it is normal. That is a case of a non-pathologic left axis deviation. Now, let's visualize now how to calculate now this axis deviation. Now, in order for you to visualize the axis deviation, you have to point out the fact that you must use the limb lead 1 and limb lead AVF. Those are the two major leads that you use in order to visualize the axis deviation. Now, after visualizing axis deviation with both of these leads, you now use, if you have a case of a left axis deviation, in order for you to distinguish if it is a pathologic from a non-pathologic left axis deviation, we now use limb lead 2. So let's have this on a vectorial representation. So here is limb lead AVF, here is limb lead 1, here is limb lead 2 here. No, let's first remove limb lead 2. Now, let's say that you have a wave like this on limb lead 2. In limb lead 2, let's say that you have a wave like this. Okay. So if you have a wave like this on limb lead 2, it means that it is predominantly positive. Okay. And let's say that you have a wave like this on AVF. AVF, you have something also like this. Okay. Something like this. Okay. On AVF. So you see that if you have a wave like this on limb lead 2, it's going to be predominant. There is more of positive side is equal than negative side, so it's predominantly positive. And on AVF, you also see that it is predominantly positive than negative, so it's going to be positive. So it means that what, if you plot it on a graph, you see that if you have a positive corresponds to here, and you have another positive on AVF, another positive corresponds to here, positive of AVF goes downward. It means that the axis deviation is going to be in this quadrant here. Is it clear? And this quadrant here is inside the normal axis deviation. It means that it is normal. Are you understanding? So that's the first point. The next point is on limb lead 1. Let's say that you have a wave like this on limb lead 1. Is it clear? On limb lead 1, let's say that you have a wave like this, and on limb lead AVF, let's say that you have a wave like this. So this is on AVF. So on limb lead 1, you see that it is predominantly negative. And on limb lead AVF, when you visualize it very well, it is predominantly positive. So it means that you are going to have a positive wave that is going to be on AVF. Positive of AVF goes downward. Positive wave on AVF. Now, on limb lead 1, positive goes in this direction. So the negative limb lead 1 is going to move in this direction. Negative. Is it clear? So it means that the wave is going to be, the axis deviation is going to be corresponding in this direction here. So that corresponds to the right axis deviation. Is it clear? So if you have a patient that has a negative limb lead 1 and a positive AVF, it is a negative axis, a right axis deviation. Now, let's say similarly that in in limb lead 1, you instead have this wave here, P wave, and then you have QRS, you have predominantly negative wave, and then in AVR, you have also this, a predominantly negative wave. So if both of them are predominantly negative, it means that the limb lead 1 is going to be negative here, and limb lead AVR is going to be negative here. Is it clear? So it means that it's going to be in the intermediate axis deviation here. Now, lastly, let's say that you have a wave like this on limb lead 1. On limb lead 1, you have a wave as such. So you have a wave as such. Are you understanding? On limb lead 1, a predominantly positive wave on limb lead 1, and on limb lead AVF, you have instead a wave as such. So this predominantly negative. So if you have a predominantly positive and a predominantly negative wave on limb lead 1, is going to correspond to here and here. Is it clear? So here is going to be a left axis deviation. Are you understanding? Now, left axis deviation can be a pathologic and non-pathologic left axis deviation because there is a side of left axis deviation that corresponds to the normal axis deviation, as I've explained later. Is it clear? So in order for you to understand if this left axis deviation is pathologic or non-pathologic, you now use the next wave, which is the L wave. Is it the L2 electrode? Is it clear? The L2 electrode. Now you need to know that what? If on L2 electrode it is positive, it means that it's going to be much more in this direction. Is it clear? So it's going to be much more on the inferior, because initially you have a left axis deviation, but if you have a positive limb lead 2 wave, it's going to be much more down on this side here, and this side corresponds to a normal axis deviation. So initially you have a left axis deviation that is normal, so it is a non-pathologic left axis deviation. Is it clear? But now if you use a limit 2 and it is negative, negative is going to move in the opposite direction. If you use a limit 2 is negative, going to move in opposite direction, means that it's going to be in this quadrant, but it's going to be much more upward than downward. And if it is upward in located here, it's going to be corresponding to a pathologic left axis deviation. Is it clear? So those are the different elements that you have to visualize for the axis deviation. Are you understanding? So afterwards, we are now going to see the next point, which is the